So, hi everyone, my name is Pawan Kumar CH, and today I'm going to walk through you all regarding my recent project. So, recently I worked on a rank system, multi-pronged rank system for a university for educational content generation. So, let's talk about something we all experience, the struggle of creating educational content. We all seen how the tech is becoming more massive part of the education, right? With the shift and the demand for the quicker and better content has absolutely taken off. So traditionally creating question and answers and summarizing it is a painful process. You sit down, think and write before you know it. Hours have passed, so and let's be honest, it's not just a slow, and it's also lead to errors and even issues around intellectual properties. But there are our AI powered content generation engine comes in. We have developed a tool that automates the entire workflow using open source LLMs and Google Gemini Flash model and Pro model as well. So the local open source models are like Llama 3.1, Mistral 12 billion and 12 billion parameter, Pi 3 14 billion parameter, and Gemma and it's 9 billion parameter, and many more we can use. And this engine takes the text from the PDFs and turns it well crafted question and answer automatically. Pretty cool, right? Now, at the heart of the system, a large language models, which are superpower when it comes to understanding and manipulating the text, thanks to these LLMs and smart natural language processing. So I'll take you through my code. Okay. So I have done two versions of it of this project. So one is file is of Gemini model. So it takes the Gemini models through uh, API, and other is like other will be running on my. So I have done two versions of this project. One is of Gemini model, and other is of local LLM model. So I quickly run to my code. Okay, this is for Gemini. Okay, here I have imported the Gemini models to this Google API key from this env file, and these are all the different 37 prompt templates that I have mapped and that I have dynamically mapped into this in this file through this file. In this, you can see these are the instructions, and you can change a lot of instructions. And I will show in that thing. I have added more context in that thing. So these are all 37 prompts, and these will be all dynamically taken into this file. So you can see the default and graph of thought, a tree of thought. So I like that I have implemented over 37 prompts. So this is the function to get PDF text, and it will take the text from the PDFs, and then it will make the chunks of it, and then it will store locally. And here I'm using the Google embedding model 0001, and I'm storing it locally here vector. I think the fast is index. This is the storing, like it will convert the textual data of the PDFs into the embeddings, and then dense embeddings, and then it will store into this file, this location. Conversational chain. So this is the chain. So here I'm using the chat Google Generative AI from Google Generative AI, and model I'm using a Gemini 1.5 Flash, and I can also use Pro also as well. And I have set the temperature 0.3, and here the prompt template, select prompt template. So what I have done is like, so this is the option. So instead of writing the hard code prompt here, I'm just selecting from this file. So where is this file? This is file. In this file, I have given each and I'm mapping them. So I have selected and input variables, context and question. So it is a format that it needs to have, and chain, load QA chain and model and chain type stuff. Prompt equal to prompt. Yeah. So user input, so user question, select prompt template. So this function will take question and select prompt template. And it will search the relevant documents in that thing and embeddings. Allow dangerous serialization true. Okay. Similarity search. First, it will do the similarity search and then get conversational sense. In this one, it will select the mapping prompts that I have mapped. So the response, so input documents, docs, question, and here that is, and the main function. In this main function, this is all the Streamlit part. So here the prompt technique select box I have created. Okay, let's go to that thing. Where is it? Here. So you see, yeah, this is the select box. In this one, I need to upload a file. I already uploaded because and you see I have the question, what is self-attention mechanism? So I have uploaded the file called attention is all you need. research paper of 2017. So I used the graph of thought technique, and it gave me like nodes and edges. So sometimes it gives graph, but in this scenario, just gave the nodes and edges like this. So it gives like graphical representations like a tree, in CMD, right? So like that. So it gave this a summary in some and summarization as well. And if you ask the question, so here I asked the question and I asked for summarization. So it gave me summarization. If I ask the questions, it will create the questions. So that is what this part of this thing. And other thing is like this is of local, completely local. Actually, I run very long, but it's still taking because it requires more RAM. So it's taking. I'm using 8 billion parameter model of Llama. So it's taking more time to generate content with my local laptop. So here also I imported like the main what I thought like best prompt techniques. So I imported only this thing, and I have also included multiple models. So these are all multiple models. So Gemma, Pi 3, and Mistral like 12 billion. So this one is running through my local, and these are the 4 LLMs. And in that I have I tried this on Lightning AI like online portal, like in where I can get the GPUs for like Tesla T4 GPU. I have run and I have done. So you see this now it got generated. It took more than 10 minutes to run this like 8 billion parameter model in my local system. So it's not the issue here. It will generate more context if you have the computing power. And here also I uploaded the same file what I have uploaded in that this file. So this is for Gemini, and it gave like a note. I use this technique, and if I select any other technique, like you see, these are all 37 techniques. Like each one is having different response, self-refinement. It will take some time to run. It will give generate. And in this also I uploaded only like few of them. In this also I try to do more, but because I'm having the issue of like RAM issue, like 16 GB is not enough for this model to run locally, even 8 billion parameters. So these all models can run. And in Google Colab I have run, it works very fine and give more context like whatever here it has given in Tesla T4 graphic card. So let's go to this part of the code. So this is the local LLMs. So in this I mapped similarly I mapped what I have mapped like 37 prompts. I mapped 6 prompts over here, and these are the models that I have mapped. And same I'm here I use the process, and here I use like from PDF text I use PDF plumber loaders. So what is this part is like, it will also extract the graphs or any other table content like it is there. So it will assign like /t for table and /g for graphs. Like it will also extract those data and it will convert into embeddings. So I have given 7,500 over here, chunk size and overlapping 100, and generate embeddings. I'm using Nomad embeddings. This is also a open source, and this is very best embedding, free open source embedding. And I use local. I downloaded it through. I all downloaded through this in Llama framework. And in VectorDB, I have selected ChromaDB. ChromaDB is the best DB, and I did the query model. In this model, it will take VectorDB and question and selecting prompt template and selecting model. In this only all it will have these options: select prompt template and select query model. So what I have done is like query prompt, select prompt template. Where is the prompt templates? You ask, like if these are the prompt templates. So not this one. These are the prompt templates. So here I gave more of the context. I have gave like step by step. These are all different prompts. So like default prompt, MCQ generating prompts, and chain of thought prompts, and like these are like many 6-7 prompts I have developed. These are the best prompts. I gave more context in this thing. And where is the file? Yeah, over here I have mapped over here to select prompts. Like I just mapped over here, and this same as the models I have mapped over here. And so basically what it does now, it will take the models. So I will show you in the deployment part only. Okay, what is this thing? Yeah, here it will take the prompt templates, and it will take the suitable prompt template of creating questions and generation, and you can select the models. For this it is running in locally, so it's running with my RAM and with my graphic card, so it's taking more time. I don't have that much resources in my local system, so it is like that. And on the other hand, so it already generated the response. This is through API. I'm trying different versions of this thing with the API as well. I'm using what called replicate. In this replicate I created a different version. I did like I'm trying to run. So if you see local LLMs, these are running, these are all downloaded in my local system, and these are all open what we call the API key from replicate. Replicate is a website where you can get free open LLM like API service, but it has some quota system over there. So it's not free. You have to pay as you go service like that kind. And similar everything is similar. So here it takes the API models, it will run through and it will generate the content. So that is what I'm doing. And I am trying to do on sequential modeling as well, like multi agents.